Did you find the spot called binomial expansion, Pascal's triangle?
Yes.
Okay, we're going to make Pascal's triangle. So I got us started. I'm going to give you the next couple rows, and I'm going to see if you can keep going. So here's the triangle. The next row would be a 1, 3, 3, 1. The next row would be 1, 4, 6, 4, 1. I'll give you one more, and then you have to figure out what's going on. 1, 5, 10, 10, 5, 1. Okay, get the next one. Did you get it? So you're always adding the 2 ahead of it. Okay. Now, there's also a connection to what we've been doing with our combinations and permutations. So, what does this match to? In your calculator, if you do 6, choose 0, 6, choose 1, 6, choose 2, this would match 6, choose 3, 6, choose 4, 6, choose 5, and this would match 6, choose 6. Want to try one of them out? Try 6, choose 2 in your calculator to see if it does in fact equal 16 or 15. Is 1.
But 6
There's
choose 6 is also 1.
Is 6.
6 choose 6.
6 choose 6 is also 1. Because if I have 6 people and I need to choose 6 people, how many ways can I do that? I can only do that in one
But
way.
if you have 6 and you have to choose 0, how is that 1?
There's only one way you can pick 0 people. Just picking 0 people. Did it work? Did it match? Okay, so what does this all have to do with anything? What we're going to learn is that when you have a binomial, so this is a binomial, if it is to the 6th degree, the coefficients will connect to all these numbers. Okay, you ready? Let's go the long way here. Okay, so if you did this binomial to the 0 degree, what's anything? Doesn't matter what you put in there. What's anything to the 0 degree? 1. If you did this to the 1st degree, it would be just 1x plus 1y. Normally I don't write the 1's in there, but I am specifically doing that so you can see. Okay, let's do, actually I'm going to do it over here on the side a little bit more. I'm going to go over to the side and let's do x plus y squared. So first is x squared. Outside times outside is xy. Inside times inside is an xy. And last times last is y squared. That's my FOIL, right? Did you see I just did the 4 parts of the FOIL? And then these are the same. So 1x squared plus 2xy plus 1y squared. now, can you imagine yourself, no, I don't want you to write this down, but you're just going to believe me here. So the result of that was x squared plus 2xy plus y squared. Okay, so we're going to cube it. So we already squared it, so now I have to do it times another x plus y. Help me out here. I'm going to have to FOIL like this. Okay, don't write it down. Let's just see if we can get it together. So x squared times x cubed. X squared times y, x squared y. Okay, now I'm going to take this times this, which makes 2x squared y. Do you see that? 2x squared y. I'm going to take this, which is 2xy squared. Okay, now I'm going to take this set. This is xy squared. And then I'm going to take the last set, y squared, or y cubed. That can go together. So x cubed plus 3 of those terms. These are the same as each other, plus 3 of those terms, and then plus y cubed. Okay? Now you can write that down, the result. Put your ones in front of those just so we know. 1. Okay? So do you believe me that that's how we got this answer? Does that make sense? You're never going to have to do this long way, but because it might take you forever. If you have to do this binomial to the 10th degree, do you really want to times this 10 times? Probably not. Okay, now, are you seeing anything? Look at your triangle above. Is there any connections? Look at your triangle stuff. Do you see anything happening? This had a 1. This had a 1 coefficient, 1 coefficient. This has a 1, 2, 1. This has a 1, 3, 3, 1. Okay, so the next is going to be 1x fourth plus, what's the next number? 4 x cubed y. What's the next digit? 6. What's going to happen to the x? How many x's do you think there's going to be? This has a fourth. This has a cubed. This has a squared. How many y's do you think there would be then? Y squared plus, what's the next? 4. There's only just one x now. Y cubed. And then the last one is 1 y4. Do you see the pattern? So the digits, the coefficients, we're calling them the coefficients, come from the triangle, which are the choosing, the combination numbers. And then do you notice how my degree of x goes 4, 3, 2, 1, 0. And the degrees of the y go 0, 1, 2, 3, 4. The y's go up, the x's go down. The degrees always have to add to the original degree. So if this is a 4th degree, see how there's an x squared and a y squared? That's a total of 4 exponents. Okay, I'm going to change this question. Expand x minus y to the 6th. So this time, there's a negative in there. So we did 6 up top. Everybody still has that on their triangle? Okay, so there's going to be 7 terms that come out of this. So I'm going to write 1, I'm going to leave some space, -6, positive 15, negative 20, positive 15, positive, negative, positive, negative, positive, negative, positive. Those are my numbers. Okay, so when there was a negative involved here, this is positive, this is negative, then the first term starts positive, the second term will start negative then. Okay, so you have to pay attention to that. Okay, so this one will be an x6 on it. And I'm going to go through and do all my x's. So x5, x4, x3, x2, x1, no x. I'm now going to go back and do all my y's. So the first term has no y, and then a y squared, a y cubed, a y4, a y5, and a y6. Was that a lot faster than doing it by hand 6 times and foiling it all out and foiling it all out, foiling it? That would take an entire page. This was already cubing something, so. Okay, here's another thing to note. If the exponent is 6, how many different terms did we actually end up with? Can you count? How many terms are there?
7.
There's actually 7 terms. Big important thing to know. So you always end up with 1 extra term, and here's why. Because we start counting at 0. So here, when you start counting at 0, it messes up your counting. So do you notice how this is the 4th term, right? 1, 2, 3, 4. This is the 4th term, but I'm actually doing the choose 3 because I start counting at 0. It's horrible for your brain, but you have to start counting at 0, which makes everything 1 different than what your brain normally would do, right? So it's because of the starting counting at 0, that's why you have 7 terms. So term 4 actually had a 6 choose 3 because I'm choosing 0, 1, 2, 3. Okay, I don't know if you can wrap your brain around that. It's kind of a little messed up. Okay. So here's this formula. It's on your formula sheet. It's kind of confusing. So let's just go with it. And instead of trying to plug it into the formula, let's just see if we can figure it out. Okay, so here's the first 3 terms. So the 4th term, here's what I'm going to do. The exponent is 4. Choose. If you pick the 4th term, what is your choosing number? 3. Bracket the first thing, which is x squared, the first unit. I'm going to leave I have to put an exponent in, but we'll do it later. Bracket the second unit, 4x cubed or 4y cubed. Now, this exponent matches, so whatever this choose number was is this exponent. And this exponent is the subtraction. So our exponent needs to make 4, so this has to be a 1. Okay, so in your calculator, you would do the choosing. So 4 choose 3 would go into my calculator. Which is just 4. X squared to the 1 is just x squared. Now, I have to cube this. So I have to do 4 cubed, because it's a coefficient. So 4 times 4 times 4, 4 cubed, which is 64. Y to the, what's the rule? You learned this in grade 9. Multiply or add is the question. Is it 6 or is it 9? How many people guessed the 50-50 question right? Should I super quick grade 9? X squared times an x to the 8th equals x 10th. X squared to the 8th equals x 16th. What else did you learn? X8 divided by x squared equals x6, right? Remember that stuff? And what else did you learn in grade 9 that might be very helpful here? X to the negative 2. Do you remember negative exponents? Scary or remember? 1 over x squared. You learned that all in grade 9? And then summing, recapped it in grade 10?
Sure. Yeah. Okay.
Negative exponents? Yes, you did. Yes, you did.
Well, you can't really blame them because the whole grade 9 was messed up.
Your grade 9 year was your messed up year?
And also 10.
And 10?
Yeah, our math
Everything in
foundation.
grade 9 got cut off and then it didn't matter because your grades didn't matter.
Okay, well that's what you were supposed to learn. Okay, everybody, did you write that down somewhere?
We're ready.
Wait till our log exponent unit, when that all comes back, heavy duty time. So you have a negative rule, you have the multiplication rule, you have the power rule, and the division rule.
It's gonna break soon. But I have to lean back on the beam on. Like, I can calculate, but
Okay, after grade 9, we jump right straight to this. So I'm just going to do the 4 times 64. So 256 x squared 9 y9. That is the 4th term in the expansion. Think about how much better this is than expanding this by hand. Okay, so the last term, which is term 5, you would do 4 choose 4. Because if you're getting to term 5, the choose number is just 4, right? 1 less. Write x squared, write 4y cubed. Then, what did we say? This exponent has to match the choose number. And this exponent has to make it add to 4 or whatever, right? Or subtract. Okay, so 4 choose 4 is just 1, by the way. Anything to the 0 is just 1. Then my number here, we're going to have to do 4 to the 4th, so I think that is 256. Y to the, what are you going to write there? 12. Okay, so that's the gist of it. So you could see how I went along. Do you see the pattern? I wrote a bunch in here so you can kind of see the pattern. Whoa, I guess you can't see it when it's fuzzy. So this exponent started at a 4, 3, 2, 1, 0. Just like how we started with our x. It went down. And then this unit went up. 0, 1, 2, 3, 4. And then we started with 4, choose 0, 4, choose 1, 4, choose 2, 4, choose 3, 4, choose 4. And because this is a fourth exponent, how many terms did we end up with? 5 terms. You always get one extra because of the 0 count. Okay, find the fourth term. Okay, so 6 choose, because 6 is from the exponent. If I'm on the fourth term, what is my choose number? 3. One less, because your fourth term is only the third choose, because you chose a 0 first, and then a 1, and then a 2, and then a 3. That's the fourth term. X cubed in a bracket, 4y squared in a bracket. This number has to match your choose number. This number is the exponent subtract the outside. Okay, so calculator would be this, 6 choose 3 in the calculator to get a number. X to the 9th, because of the rule, right? Now we got that rule down pat. And, okay, 4 cubed is 64. Y to the 6th. Okay, and on the last step, I simplified by just doing the number 20 times the number 64. That's where I would have got that.
What's the equation on top of this?
What am I looking at?
Like, what's that equation thing at the top?
This? This?
No, yeah, that.
This is what's on your formula sheet. It's confusing.
Okay. So are we just skipping it or what?
So you can look at it, but like, do you see N would be like that? Choose the K, and the K is always one lower than the term.
So it is what we just did.
It's just what we did.
writing out.
I just hate using the formula. I just like to just go to it.
Okay.
Yeah. But not really is what you're going to say?
Well, what does this equation solve? What would I use?
It's a very short way of doing, like, if I needed to do a binomial to the 6th, do you really want to do this? Do you really want to multiply this, FOIL, and then after you FOIL that, you have to FOIL by that, and then by another, and do you really want to do that 6 times? Do you know how long that would be? You wouldn't be able to fit it on the whiteboard, right? So now this is a shortcut. Okay, find the 7th term if you were to expand this binomial. So instead of doing it by hand. So what choose what? Where do you get your starter number from? The exponent. Exponent is the starter, so 10. Now it's a choosing the 6, because I'm on the 7th term, so that's my 6, because of that stinking 0. Brackets 3x squared, brackets negative 4x. You need the negative in there. So do you see these exponents? I always go to this one, you see on my formula sheet, this outside one has to match. So this outside one is 6. The inside one is when you subtract them, so the inside one is a 4. Okay, so the rest is calculator stuff. So 3 to the 4th is 81. Did you get an x8 on those ones? X8. Can you tell me if this is positive or negative when you do that? Positive, right? I get people who type that into their calculator wrong and they get a negative. Well, just think ahead. -4 to a 6th even degree should be positive. Positive. So your final answer, you can put all of those numbers multiplied together. All of them, which is going to be big. Yikes. Really big? Really big, right? And this time, versus last time we had x's and y's. This time we have x's and more x's. So x to the 14. Okay.
Yeah, give it up. We'll watch it.
I'm going to rewrite this. If it has moved to the bottom, I can move it back up to the top by making the exponent negative. 3x negative 3 is the same as that. So that's your negative rule. Does that make sense as a rule? Do you remember that rule? Okay, so choose. What's the exponent number we start with? 7 is the exponent. And if we're going to choose the what in the 5th term, what's your choosing number now? 4. You give yourself 2 brackets. So 2x squared is in the one. 3x negative 3 is in the other one. The outside exponent has to match the choose number. So that's a 4, and then the inside exponent is a 3. Okay, work away. Let's see if you can get your answer. Go ahead with the rest on your own. See if we can match. So don't look at mine until you're done.
I'm still pressing shift and then another button. So it's almost the same.
A little bit backwards. Okay, backwards types. So now, which term would end up with an x 12th in it? Okay, so I only care about x's. I only care about the x parts. So in other words, I'm not going to care about this part. I'm not going to care about the coefficient, So I'm only taking the x parts. Okay, so the x parts in the first unit is an x fifth. The x parts of the second unit is an x negative 2. You see that? Because look at it, it's on the bottom, so now it's a negative 2. This time, I don't know which term, I don't know my choosing number, so I'm going to put a k on the outside. Then, what do you know about this exponent? What did we always do? What's the rule? How did we always get to this one? It's the subtraction number. So 8 minus k. Where's my 8 coming from? The exponent. Every exponent, the two exponents, always have to add to the original exponent. Out of all those x's, I want to end up with an x12. That's the goal, right? So I only took the x portions, and this time, instead of knowing the term number, I want to figure out the term number. Okay, so this is an x to the 40 minus 5k. See what I did there? I multiplied that, right? Because that's the rule. Times an x to the negative 2k. We okay with what I did? I multiplied, that's all I did, was the multiplication rule. Power. Okay, now when it looks like this, what's the rule with the exponents? Now you need to add the exponents. So there's my rules, right? Know when to multiply your exponents. This would be an add exponent. Are you guys okay if I drop my x at this point? I'm making the conclusion that this exponent has to equal that. Is that going to make sense to you? 40 minus 7k has to equal 12. Does that make sense? If the base is both x, therefore we're just saying in math the exponents have to equal each other. So negative 7k equals negative 28. So k equals 4. But that's not even my answer. That's my choose number. K is my choose number. So which term am I actually on? 5. It's the 5th term. That's your answer. If your choose number was 4, that means you were on the 5th term.